Hey folks, Cool18 here, and welcome to another tutorial for Unity 3D and TileMaps. And now we're really going to get to the sort of hardcore, actual functional TileMaps, because up until now we've been working purely in this sort of graphic layer to demonstrate some of the concepts, but that's not actually the way you make the game work. And I mentioned in the previous video that one of the things we're going to do is separate the gameplay logic from the graphic logic. And the reasons are, A, it can keep things a little bit simpler. B, it can give you more opportunities to optimize certain performance. And C, it gives you the flexibility of changing how your graphic system works without having to affect your gameplay logic at all. Also, it actually gives you certain types of opportunity to do some like multi-threading, for example, because you can have the gameplay logic running one thread and then the graphical updates running in another. And also, again, it gives you the opportunity to change the look of the graphics without having to rewrite all the gameplay logic. For example, if we were turning this around and deciding to make a dungeon crawler, and then, we've been working in a sort of pure 2D setup up until this point, but we decide that, this is kind of boring, we'd much rather go for a sort of 3/4 view, and seeing as we're looking at it this way, we'd like the walls to have actual heights, to be, three-dimensional objects, and not have everything be completely flat. And we might want to have the water have certain types of different animations, right? The gameplay logic doesn't need to know that the water is animated with waves or laps up onto the shore from time to time. And so by separating it all out, we're giving a few opportunities to do that sort of thing. So I'm gonna start working on this gameplay logic, and we're gonna keep the tile map logic relatively simple because it's going to be very generalized as well to actually go and to actually go and make a game. It's going to be relatively specialized based on what kind of game you're making. So I think I had the extra plane in the last video, which I've just gone and delete just to clean up. But other than that, we're pretty much where we are. However, we're probably going to throw most of this away and rewrite a fair amount of it. But before we get to that point, we're just going to start working on the data layer. And so visually, I don't know if there's going to be a whole lot that you can see to demonstrate that it's going to work in this video. We're mostly going to work with the background logic. So I'm going to create a new folder. And I'm going to call this is going to be everything related to my tile data layer. Right? This is just where I keep tile data. There's going to be classes related to tile data. And I'm going to create my C# scripts, and I'm going to call them TD_map and TD_tile. So this is just going to hold tile data as opposed to, and it's a gameplay layer as opposed to graphical information. So I'm just calling them this so that I know when I'm working that I'm specifically using the class that is just the data type class, completely isolated and separated from the graphics. You can name them whatever you want, of course, and assuming you're working in a sort of a full-blown proper C# environment, you can use namespaces and all kinds of things, but I don't believe that Unity 3D supports namespaces. I think you can put it in, but I don't think it actually, truly uses it properly. So we'll just pretend they don't exist. So I'm gonna open this in Mono Develop. There we go, TD tile, and we'll open the TD map as well. Now the first thing we're going to do is actually strip out the Unity logic stuff, because again, these are independent from Unity. They have nothing to do with it. I can probably get rid of the collections thing. We may use it, we may not, I don't know. We can get rid of that. We are not going to be derived from mono behavior, and we don't need these functions because these functions don't actually exist outside of a mono behavior. So we're going to get rid of those, and we'll do the same thing over here as well. We're going to strip these down to just pure bare bones C# classes. And we're going to start with the TD tile class, which is just responsible for holding information about a tile, a singular tile. And really the only thing it kind of needs is, at this point anyway, it needs to know its type. That's the bare minimum. It needs to know what type of tile it is. And there's a few different ways of implementing this. Well, there's a few different ways of implementing just about anything. But we're just going to use, I'll set it as a public for now, because we're going to take the lazy approach and make some of the things public, and then later on we can make things private and encapsulate things in accessor functions if need be. We're going to just use an integer to hold our type. And we'll have it default to 0. And what does that represent? Because there's lots of different ways to do this. We could use some enums, which actually would be probably a much better idea. There's all kinds of different ways that we can do this. But so a type 0 will be considered ocean, and then our type 1, if I go over to my graphic, which I'm going to use as the sort of guidepost here. Type 1 is going to be grass, type 2 is going to be plains, and type 3 is going to be a mountain. So everything's going to start as ocean, and then we'll change it up. So again, enums might be better, right? Because what we could do is do something like enum type, and then ocean, grass, plain, and mountain, and then make this type, and then set it to type dot ocean to start off with. And this way, when you code, then you're using actual words as opposed to just numbers. We're just going to use numbers for now, just to sort of keep everything as minimalist as possible. And of course, we can always set up constants, right? I can set up a constant integer tile underscore ocean equals 0, and then do that. And if it's actually set to a public, we can even reference this from outside. Actually, this can be a static. Being constant, is it implied that it's a static? Let me see something. This is actually something I'm quite curious about. tdtile.tileOcean. I bet you it is. Int a equals that. Sorry, I'm totally sidetracking myself here. That is a legal assignment. Ah, cool. What the hell am I talking about? Well, normally you can't access, like I can't access, I can't go tdtile.type, for example. That is going to generate an error because this is a member variable of tdtile. So we need an actual tdtile. I would have to go tdtile t equals new tdtile, and then I can go t.type. That is totally fine. And then there's static variables, which belong to the class as a whole. And apparently const implies static, which today I learned. Or today I probably relearned. So sorry for sidetracking things. Okay, so we have tdtile, we have a type assigned, and you know what? Let's go ahead and create some constants just to do that. Again, an enum is probably better, but we're going to do this for now. We're going to call it plain and a mountain, and we're going to tab just to get everything aligned nicely. 3, 2, 1. Okay, so good. That is set. So at this point, this is all the tile needs to know about itself. It just needs to know what kind of tile it is. We might change that considerably going forward, but for now it's good enough. Now our TD map is going to have what? Well, it's going to have to contain all of the tiles, right? So you can imagine we need an array of tiles. Now there's two ways we can go about this. We can create a two-dimensional array of tiles. And that way later when we have a function, some sort of function, then we can reference tiles, some x coordinate and y coordinate, and do something with it, right? That's one way of doing it. The other way is to use a single dimensional array, just a more conventional array, in which case what we need to do is something like y times map width plus x dot type. Which way is better, which way leads to simpler code, which way is more optimized. It's kind of all toss-ups. I think I'm going to use the single dimensional array, just because, again, I'm going to try to use the least amount of fancy code tricks as possible in my implementation. So we're just going to use this, which is fine. So we're going to need our first constructor function. So when you're working in Unity and you're working with a mono behavior, you're used to doing something like void start, initialize stuff here. And that works fine in mono behavior classes. And in fact, you don't want to use a constructor in mono behavior classes because they have their own constructors that do things, that handle certain types of serialization and different stuff. So you never want to have an actual constructor in a Unity mono behavior subclass. But this is a regular C# subclass or regular C# class that isn't subclassed for anything except for the implicit object class, of course. So we need, if we want to initialize stuff, we need a constructor. So that is simply a function named after the class, like that. We need to make it public if we want other things to be able to instantiate this object, right? If we want something to be able to say new TD map then it needs to be public. And there are reasons why you might not want to have a public constructor. This is actually implied, by the way. This sort of empty constructor will automatically exist if you don't create a constructor at all. But it's worth noting if for some reason you have a width int height, if you have a constructor at all, for example here one that uses parameters, then it no longer creates the empty one. So you can no longer say new TD map because there shouldn't be a constructor that matches that. Assuming I'm not confusing myself with other languages again, but I'm pretty sure that's the case. So this is not going to be a full C# tutorial because that's way outside the scope of a video. If any of this is confusing, either it's because I'm making a bad job of explaining things, or B, you need to just pick up a basic tutorial for C#, just C# for Dummies or something, which that's how I learned programming, those sorts of books. So, all right, so we have an array, and yeah, actually we do need to probably specify some sort of width and height for our map. And we probably want to store those somewhere. I'm going to use a private variable. In fact, tiles, is it public, is it private? In fact, I think it's probably, we're going to make it a public for now because we're going to use this later in our graphic thing. Again, for proper encapsulation, we probably want these to be protected or private, and then create various types of accessor functions. You know what, let's just leave it protected for now, and we'll come back to it. Now, by convention in C#, protected stuff, you put an underscore in front of it to indicate that. So this makes it clear that no one outside of this class will be able to actually access tiles because it's not public. So let's keep going with that. So we have a width and a height, and those are going to be assigned here. So our private width is being assigned from this, and our private height is being assigned from height. And then our private tiles is going to be a new TD tile array of size width times height, like so. We could also do an overloaded constructor, TD map, like this, which does something like just call the other version of TD map with, some default values. We could do that sort of thing. I think I'm going to leave it out like this. Makes it so that when the game creates a map, it just has to explicitly pass us this information. We could also put in some, we do the default value thing, but let's do this. This is going to be fine. So we've instantiated our tiles array. It's the correct size. Right now, everything is defaulting to ocean tiles. I suppose we could populate it with some random data again, just to see what happens. Actually, hold on. Let me leave it like this for now. Yeah, this will be fine. And this is actually all we need to do at this point to end up with a new perfectly blue map, right? So what we need is our graphic code to start reading this data. And I did say this video wasn't going to have anything graphical, but I think when I was saying that, I was thinking we'd do more work here, but I kind of like the idea of keeping it as dead simple as possible at this time so that we can go and fill in some blanks. We will create one helper function here. Public, it returns a tile, and it's going to be called getTile, and it needs an X and a Y coordinate. And all it will do is it will return from our tiles array the ones at Y times width plus X. However, before it does that, it will do a sanity check. It'll make sure that if X is less than 0 or X is greater than width, actually greater or equal then, because this is going to be 0 indexed, right? So if our width is a width of, say, 100, we can't actually allow X to be 100 because it goes from 0 to 99, okay? Or Y is less than 0, or Y is greater or equal to height, then we will, what are we going to do? We could do all kinds of things. Probably, we want to throw exceptions or something like that. For now, we'll just return null. And that way our program at the other end can just check to see if it's null. Or more accurately, what will probably happen is we won't check for nullness at all. We'll just let the program throw an error and then we'll debug it from there because, we're doing the absolute minimum amount of work. We're not necessarily designing the best program for sort of robustness at this point. But, we're at least doing a little bit of a check here. That's worth something. Right? Okay. And you know what? We can, I was going to say we can do a debug.log, but we can't do that unless we keep in the using Unity engine code. So, we might want to put it back in for debugging the easy, silly way. Again, we're not using the proper debugger. We're just logging things. But, this will be fine. This is simple enough as is. We'll probably end up putting that back in, but we'll leave it out for now. So let's go ahead back to our graphic layer. Okay, so we have our tile data information. And we have our tile map object, and on it, there's a tile map script. We're going to, what are we going to do? I feel like I might, I'm going to create a new folder, and we're going to start semi from scratch here. We're going to create a new folder, and we're going to call this tile graphics. Okay, so we have our data layer, and we have our graphics layer. And I'm going to grab the tile map code. I'm going to paste it in here. Can't copy and paste, really? Okay, Control D to duplicate, drop it in tile graphics, put it in here. We're going to rename this, we're going to use TG for tile graphics and call it map. TG map. And then I'm going to open this up. And one of the things is the tile map, the class needs to be changed. This is going to be TG map. And what else is it going to do? Well, you know what? I'm going to get rid of the execute in edit mode. Yeah, it's going to be fine, and we're going to still use the inspector helper down the road. We need all these things on the object, so that is totally fine. We can set these things, that's great. Most of this is going to stay fine. I want to redo the build mesh function so that it's not doing the linked mesh thing, but instead it's doing the thing where each quad is unique. And also, we don't need to build a texture anymore, but what we do need to do is map the texture from one to the other. In fact, there's a few things we can do. For example, let's go over here, and we are going to our textures. What do I want to do? You know what? I'm going to delete some things. I'm going to delete the tile map. I'm going to delete the tile manager, the selector. We'll leave in the camera and the directional light. We're going to create a new empty because we're going to have a brand new tile map object. We're going to go to 0, 0, 0. We're going to leave it empty. I'm not going to call build mesh. Actually, it doesn't matter because it doesn't run in the editor. But we should be able to apply this script to that. It'll add in our collider, our renderer, our mesh filter, which is great. And then I'm going to drop this in this folder. I'm going to also bring our textures over there. I'm mostly going to delete this stuff. We're going to clear this out. Leave the scene object, selection cube, the textures is empty. Tile map we no longer need. We don't need that. The mouse and script, we can get rid of all these things. I'm going to clear this all out. Get a nice blank slate. And the one thing that we're getting is the complaint on the tile map inspector because it's looking for something called, it's looking for a class called TileMap, but we don't have that anymore. We have TGMap. So I'm actually going to do that. Open this. And this is going to be our TGMap inspector. Otherwise, it's pretty much the same. Oops, like that. Okay, I think we're back in there. Still getting one error. Oh, yeah, tile map. Okay, good. So now we still get the regenerate button, but right now things are not working the way that I'm going to want them to work. There we go. Now we can pan around this object. All right, so it's still empty, which is great. That's what I want. The reason we have done all this is we're trying to create a certain amount of naming convention. So we've got TD map and we've got TG map. Maybe that's not even the most clear, right? Maybe I should have used a GFX map instead. There's something to be said for that. We'll leave it as is. It's, you know, it's not the end of the world. We don't need to chop up tiles because we are going to use the technique that I discussed where we're no longer going to be creating a 2D texture to cover the whole thing. Instead, we're just going to reference our little tile map over here and use pure UV mapping. So we don't need to chop up tiles and we don't need to build textures anymore. This can all go away completely. What we do need is some ability to map a tile type to a position in the graphic file. And that's going to be pretty easy to do. We're going to come back to it actually though. Let's redo our build mesh. In fact, I'm going to put a cut in here, and what we're going to do in the next video is we're just going to rebuild this build mesh function to work with every individual tile being its own quad. Now, just because they're not connected, just because they're not sharing vertices, doesn't mean they're not still part of the same mesh. It doesn't mean that it's going to require more draw calls to send to the graphic card. It's still going to be a very, very fast process. The only thing we lose is we're going to be sending few more vertices, but on the other hand, we're going to be setting less texture data. So overall, we're still going to come out pretty far ahead. See you next time, folks. Bye-bye.